it's really great to be here and to actually kick off this session with some remarks on the intersection of climate science, societal support, and policy. And so there's really three main themes that I'm going to be discussing. One, climate science. What is it? What do we need to know? What are the knowledge gaps? Two, what needs to be done in response to what we already know? And that really depends on what we care about, and that's the societal imperative. And then three, once we've finally decided that we need to do something, then who does what and when? And then that's where the policy imperatives come in. And so I'm going to kind of walk through those. So I represent the Office of Biological and Environmental Research within the Office of Science at DOE, or I'm going to shorten it to DOE BER from now on. So we're the fundamental science granting arm of the department. And our program actually dates back to the very beginnings of the department when it was the Atomic Energy Commission, and as a consequence of its role in the creation and use of atomic weapons. So everything that I present will be viewed through a mission lens, and I'm going to describe a research portfolio that from inception included studies of climate science. So my first theme, what is climate science? At the beginning, climate science was actually pretty simple and straightforward. If you were going to drop a bomb somewhere, where would that nuclear fallout go? Because you probably wanted to make sure that you weren't in the path of that fallout. So that led to the first studies of climate science as atmospheric circulation models, with numerical models representing physical processes in the atmosphere and the ocean. So there were only two components because that's really all that we could handle at that point. So clearly the DOE mission has expanded to include lots more in energy production, infrastructure, and security. And so there's a need for actually more accurate models that can make predictions for future climate scenarios and Earth system variability. So the models have become more refined and sophisticated, and they include now more elements than just atmosphere and water, but they include the cryosphere and land surface and recently vegetation. So they don't quite include people yet. I usually present a graphic that shows the complexity of our current thinking about the climate system, all the various physical components, aerosol compositions, clouds and energy feedbacks, plant and microbial traits and terrestrial and aquatic regimes, ocean circulation and ice reflectance. But this actually kind of serves to reinforce sort of a reductionist view of this very complex system. And I didn't really want to do what we do so typically, which is to kind of drill down and focus on a specific subcomponent so that we can kind of think about that study, simplify it, and find it more tractable. And typically then, our study of it would really depend on personal experience and personal perspective. So what we found is that that perspective is necessarily very limited unless you undertake an increasingly multidisciplinary approach that involves scientists from many different fields: meteorology, ecology, chemistry, biology, mathematics, computer science, engineering, everyone represented here in the room, and disciplines from all academic institutions and the DOE national labs. So we found that we actually need to apply all of these very complementary skills and talents to address the knowledge gaps in climate science. So DOE BER has been investing in many different types of long-term experiments, infrastructure, and observing facilities that can help to validate and improve climate models. Experiments in permafrost microbiomes, carbon and nitrogen uptake, changes in solar reflection or radiation due to clouds and aerosols. And increasingly, these experiments actually cross between different fields and disciplines, much as Keith mentioned yesterday when he referenced the Academy's new biology report. So increasingly, climate science is taking that route as well. So I get to my second point. So when do we know enough? Clearly, given an infinite funding environment, scientists would be very happy to stay indefinitely in what Sally Rockey referred to as that curiosity phase, right? They could study something forever. So, but I think that many of you probably heard that phrase, all models are good, but only some models are useful. So when do we think that we have sufficient information to be able to make use of a climate model? And that's where the societal imperative comes in. Society needs to decide why they want to use a model, and then can they trust that model? So since 1989, DOE BER has been supporting the Program for Climate Model Diagnosis and Intercomparison, or PCMDI, to compare the performance of all of the world's major climate models. So these models are unfortunately not uniformly good in every aspect, but some are better than others in certain things, and all of them actually show similar trends. So PCMDI has served as a neutral and trusted repository for documentation of model performance, including development of tools to improve visualization, performance of coupled models. Analyses from PCMDI play a key role in the foundational science underlying the IPCC assessment reports. DOE is now currently supporting development of the Energy Exascale Earth System Model, or E3SM, with the goal of running on the DOE high-performance computers that are due to come online in 2021. So this ambitious project is also a multi-institutional partnership led by the DOE National Labs. The first version of E3SM was released in April of 2018 with resolution as fine as 25 kilometers. And that actually allows you to make some predictions of things that we've heard a lot about in the news, like sea level rise. So the goal is eventually to be able to make predictions at a scale so that you can make decisions. You can site some infrastructure near a coastline, and you can feel it will be safe for the next 50 years. Or maybe you can understand how changes in sea surface temperature may intensify hurricanes. So finally, how does policy fit into the picture? Well, policy is why DOE BER is committed to providing long-term stewardship of user facilities, which is a hallmark of the DOE Office of Science. Policy is what tells all of the federal agencies to coordinate their climate research portfolios under a single entity, the U.S. Global Change Research Program, run out of the White House. So this ensures that each agency addresses a key part of the climate science puzzle in a non-redundant and complementary way. Policy also dictates that the agencies share data products and data archives and keep each other informed of scientific developments or important accomplishments. And finally, policy is also what determines which knowledge gaps are prioritized and when to make critical new investments in scientific facilities or infrastructure. So I hope I've at least set the stage for the next speakers who are going to bring in now the really critical pieces to add on to once we know what the science is that we need, which is the importance of education and training, how societal expectations and trust are engendered, and finally how federal policy is just the beginning with partnerships at the state and local level. Thank you.
Thanks, Say. I just want to say thank you to all of you for being here. I know that some of you are using your scarce continuing education funds to come to this meeting, or have found your way here through some personal sacrifice, and I really appreciate that, and I hope that you are getting value for your time and your investment. I was feeling kind of guilty about having like 30 slides for an 8-minute talk, but then I went to Dr. Moniz's talk last night. And I think he had approximately 4,200 slides for a 60-minute talk, and he didn't get through very many of them. But I was sort of verklempt with this data after, slide after slide, data after data after data, saying, you have this question? I have data for that. You have this question? I have data on that. And none of his answers would fit in a tweet, none of them. It made me really kind of sentimental. So I am going to have to go quickly. But if I really start going too fast, somebody just wave your hand and I'll slow down. So the National Center for Science Education has been around for about 30 years. We were founded on the idea of preventing creationism or intelligent design being taught alongside evolution in public schools. About 10 years ago, we added climate change to our mission because we were seeing the same kinds of attacks on the science classroom, efforts to require or encourage teachers to teach both sides of an area of science that was well established. Why am I showing this slide? This is from the Yale Climate Communications Project. And I just want to quickly take an aside to say, we just heard from Kay that there is a science of science policy. There's also a science of science communication, and there's a science of science education. We actually know a great deal about how to communicate effectively and how to educate effectively, and we should make use of that research base. What this map shows as the relative acceptance of whether humans are changing the climate across the country is at the county level. Wherever you see blue, the average acceptance of the settled science is lower than the national average. Wherever you see yellow or gold, it's higher than the national average. The point being that about 40%, it moves around, it's been getting a little better, but about 40% of the American population does not accept the statement that humans are changing the climate. The climate is changing and humans are largely responsible. And the number is not distributed evenly. There are vast parts of the country where a lot fewer than 60% accept that science. And science teachers teach there. So they are in the position, if they want to teach climate science, of knowing that their communities may be very hostile to that idea. Just a note that acceptance of climate science does not track very well with education levels or even science knowledge. What it really correlates best with is your political affiliation. You can predict whether someone accepts climate science much better by asking them which party they affiliate with than any other measure. So what does this mean for teachers? This graph shows both evolution and climate change. The bottom bar is climate science, and this is the situation in our classrooms. About 50%, a little more than 50% of science teachers, this is middle school science teachers, general science teachers in high school, biology, chemistry, physics, and earth science teachers. About half of them are teaching it appropriately. About 10% are actively telling their students that climate isn't changing or humans are not responsible. But about 40% of them are doing something in the middle. They're avoiding the topic, they're teaching it as a debate, they're not teaching straight up. The science is settled, it's as settled as any other part of science you're going to learn in high school. So, as I said, there is a science of science communication and of science education, and so we know how to teach this topic in a way that will help students overcome their misconceptions, help them learn about the science. And the answer is that you need to provide students with opportunities to act as scientists themselves. Give them an opportunity to ask questions, to go out and find the evidence they need to answer those questions, and then go back and revisit their initial understanding and ask new questions, seek new evidence. This is familiar to anybody who has practiced science themselves. May not be familiar to those of you whose last experience of science was in high school, where what you might remember as being science is memorizing a bunch of facts and regurgitating them on a test. This is how you teach science effectively. We know that for all areas of science, it's particularly critical with a topic like climate change or evolution, where the student may come in with a lot of misconceptions. We specifically, in our lessons that we've developed for teaching climate science, look at this issue that the student already has something in their brain that's extremely sticky about whether climate change is real or not. You need to know that and address that and give them an opportunity to learn for themselves facts that will correct that misconception. And then the blue bar at the bottom, the fallacy, is you also show them what was underlying that misconception that you had. For example, the acronym is FLICC, F-L-I-C-C. L stands for logical fallacy. And the lesson that I'm going to show you is working on the logical fallacy that just because something happened one way in the past, that must be the way it's happening now. So we've developed 5 lessons for climate science that can be adapted to basically any grade level and any subject that teachers can use to help students address the 5 most common misconceptions about climate change. The teachers are also given training in how to preempt conflict, because many of them are very worried about other teachers, their administrators, parents being upset about teaching this topic. We help them deal with that in advance. We have local teachers teach their peers, and we make sure that the local administration, the school administrators are on board with it. Here's what the 5 lessons cover. The science is settled, and I want you to see that intentionally I'm saying the positive, not the negative. I'm not giving you the myth. or the misconception. I'm giving you the correct information. That's very important. Modeling is a powerful tool for prediction. Modeling is the basis of really all scientific thought. That recent climate change differs dramatically from past climate change. Climate change contributes to extreme events in real ways, but they're complicated. And that there are many different ways that people can take action to solve the problem of climate change. I'm going to go through very, very quickly the lesson for how recent climate change differs dramatically from past climate change. All of these lessons are on our website for teachers to download and use. So this tool, looking at past versus present climate change, depends on a website that is from the King Center for the Visualization of Science. You can see, by the way, center is spelled, that this is in Canada, not here. This is a fantastic tool. I warn you, if you go there and start playing with this, you may lose a whole day, because it's really fun. I'm sorry the website is so long, but my slides will be available so that you can find it. Okay, so if you click on where the red arrow is, continue, you're going to get this graph. If you then click on carbon dioxide, you'll get this. This is 800,000 years of ice core data. These are carbon dioxide levels over the last 800,000 years, and you can see that they've been going up and down. And it sure looks like sometimes they've gone up and down really fast. So if you take just one look at this and someone says to you, climate's always changed, CO2's always changed, why is today different? This is the graph to play with to start correcting that misconception. So here's what you can do. You can click up there on slope tool. You can click on 2 points in the graph. It will tell you what years you're looking at, and it will tell you what the change in carbon dioxide was over that time period. You can see here that it was 0.0123 parts per million by volume per year. Somebody remember that, okay? 0.0123. You can use these sliders at the bottom to narrow in on a certain time period so that you can really go in there and find exactly the fastest change in the past. Up here, you can click on the last 5,000 years to zero in on lately. Then I've used the sliders to just look at the last few hundred years and figure out the slope for the last 160 years. 0.702. You can also do this as a linear regression. Then you get 0.718 parts per million per year. Remember what the change was in that last part that looked like the steepest part of change in the past? 0.0123. The rate of change is dramatically different. You can also look at temperature on this graph. I told you you could eat a day with this. You can look at nitrous oxide, and you can look at methane. You can look, this is temperature just over the last 160 years. You can see the data set has gotten much richer, which also means it's much noisier. And you can see that there are lots of downs as well as ups. But by looking at the linear regression, you can see that what the change has been over time. And again, if you go back and play with that graph, which is what the teachers encourage their students to do, you can see that the change now is very different. So the students may then ask, and I hope they would, why? What was causing those changes in the past? Well, then the teacher has an opportunity to teach all about the solar system level changes that affect our climate and temperature over our planet's climate and temperature over time, and that those are not sufficient to explain current climate change. So you can look at two things together and see that carbon dioxide and temperature go up and down more or less in sequence, and so do the others. It's an endless, endless playground for looking at, is current change the same or different from past change? So again, the idea is not that the teacher comes into the classroom as the sage on the stage and says, I know more than you do, you write this down and write it down on a test. It's the teacher saying, let's all behave as scientists. Let's ask a question, let's go out and find evidence, and let's figure out what's going on. This works outside the classroom as well. If any of you have that sort of iconic cranky uncle at Thanksgiving who doesn't accept climate change, I would suggest that this exact same approach works. First, establish that you're going to go try to find some evidence together to look at the evidence, ask the questions, go back and revisit your initial understanding, and be aware that you're not going to change someone's mind in one conversation. It's a process. as all of us know who have ever worked as scientists, your understanding evolves over time. You don't just get it in one experiment. There is a lot more common ground than you might think. Most people now say that they feel that climate change is having an impact in their local community. That means that when you start this conversation, you can say, what do you think's happening here? What do you think, if this climate change thing is for real, how do you think it's going to affect us in our town, and what should we be doing about it? That's the first step to then opening up somebody's willingness to look at the evidence with you. There is bipartisan support for many of the solutions to climate change. That's another place where you can find common ground and open the door to discussion. I just want to say thank you to our staff. That's it. There are 56,000 biology teachers alone in America, and we're the ones helping them teach evolution and climate change. There's 200,000 science teachers altogether. We are dependent on hundreds of volunteers who work with us, and we're very thankful for them. We are a membership organization. If any of you feel so moved to go home and rummage around in your couch and find spare change and send it to us, we would appreciate it. It'll go right out the door to teachers and graduate students who are working on communicating on these topics. Thank you.
Hi, I'm Suzanne Tagan, and I work at the Center for the New Energy Economy, where we mostly work at the state level. The center was founded and is still directed by our former governor in Colorado, Bill Ritter. And we work with governors, with governors' energy offices, with state legislators, and with utilities mostly, and many partners and stakeholders. Oops, that's not the, let's see. I have a few slides, I don't know. Anyway, I'll just, I'm not sure. Okay, I don't really need the slides anyway. So because our center is focused on policy and policymakers, I wanted to talk a little bit about the kind of the top-down approach for science and decision-making. And then I also am gonna go into the bottom-up approach, and Jan Kochis here is going to help me do that. And then I also wanted to just talk about kind of changing minds and how sometimes science will change your mind, sometimes an experience or even a disaster will change your mind about climate and climate science. So we find at the Center for the New Energy Economy that our bipartisan work is really the most impactful work that we do with state legislators. And a theme that keeps coming up here is also shared values and trust. And so one of the things that we do is called the Clean Energy Legislative Academy, and we bring 25 to 30 state legislators from around the country, Republicans and Democrats, together, and we talk about ways that they can transition to a cleaner energy economy, to the new energy economy. And we've found that state legislators are really hungry for information on climate science, on air quality, because they don't have this background. So they have to work in energy policy, but they don't have a background in energy policy. They don't have time to go do the research. And some of them don't have staff at all at the state level. So at the Academy, we take kind of small groups, and it's a really intensive 4 days in Breckenridge, Colorado, where we talk to them about renewable energy and transportation and grid modernization. And we start out by having Governor Ritter with some members of the Conservative Energy Network. And we have a really frank and open conversation about climate science and about energy policy, and how sometimes in some states it's really hard to talk about. And we have legislators there who say, well, I believe in climate science, but I have friends and colleagues who are still skeptical or who don't believe it at all. And then throughout those 4 days, it's really interesting the way that people, you can kind of just see the wheels turning in their heads, both from the more conservative side, where it seems like they're really starting to think about these issues a little bit more deeply, and on the more progressive or liberal side, where they're looking at their colleagues from a different state thinking, you really think that? So it's eye-opening, I think, for everybody, but it's great to have the Conservative Energy Network there talking about climate science communication right in the beginning and saying, we know this isn't an easy topic, and sometimes you have to meet people where they are. So it depends who you're talking to, of course, you all know that. But talking about protecting God's green earth is a way to, get into a conversation maybe with people instead of jumping right into the climate science. So sometimes meeting people where they are, and then hopefully they would be open to seeing some of the science and the evidence that Anne just presented, which was great. We also have somebody attend from Moody's Analytics, and he explains how Moody's uses the climate science and results from scientific models. And when they rate cities, for example, at Moody's, they use climate risk as part of the rating. And last fall, one of the Republican legislators stopped the guy from Moody's and said, well, you're saying that we have to believe in climate change. And the guy from Moody's said, listen, I'm a financial analyst, I'm not a scientist, but at Moody's we use the science that we know is already true because the scientific community has given us the science, and we take this and we use it in our algorithms when we're calculating risk and when we're rating cities. And so there was actually quite a debate about this and about whether this organization was then kind of saying that people had to believe in climate change, which is not what they were saying. But it was interesting, and throughout the few days that this legislator was with us, he seemed really open to kind of at least thinking about, well, if all these people in the room think the science is settled, so is the science settled? So that was eye-opening for people too, I think. And I had a slide that showed a scientist from the National Renewable Energy Lab talking with one of the state legislators in New Mexico, Nathan Small, who was one of the people responsible for their new energy goal, the Energy Transition Act in New Mexico, working towards 100% carbon neutral energy by 2045 and 2050. The photo was just there to show really one-on-one direct communication with the legislators, and I think that's important to have scientists talk directly with the state policy people or their staff. So what we do with the Academy is we have one kind of intensive workshop where the legislators are there, and then a month or two later they'll have another workshop where they send their staff, who we know are, all of you were maybe there, but they're writing the policies, right? And I do want to thank the Department of Energy for all the resource maps that we're able to show the legislators, because it's really important to say, here's your state, and these are the places where wind is the strongest, or these are the places where, solar is the strongest. And so talking about state policy and kind of the top-down, people can, enact these state policies like renewable portfolio standards or like New Mexico did, and then people in the state obviously have to follow that policy, I guess whether they believe it or not, so this is really a top-down strategy. But people like Jan Kochis, who live on the eastern plains of Colorado, she lives with her husband Virgil, and they live on his family farm that's been in his farm for over 100 years. And they're dryland wheat farmers, and there has been drought in Colorado, and so they were in trouble, and they were going to lose their family farm. Until they, as you can see kind of in the background there, they now have wind turbines on their land. And this is a story we hear a lot in the Mountain West, where the wind turbines are saving the family farm. And so people are gaining income from the wind turbines, from the wind developer or wind project owner, and they're able to stay on their family farm. And they can still farm, they're still dryland wheat farmers, and they farm around the turbines. But Jan is educating people from the bottom up, and she doesn't preach climate science, but what she's talking about is renewable energy and economics and financial gains, and she's talking about community resilience and sustainability and how communities can gain from renewable energy. And she knows that her neighbors don't believe in climate change at all in the rural plains of Colorado, but she's talking to her county commissioners she's talking to the water planners, and she's talking about how the energy that is coming from her land doesn't need water to be produced like a lot of other energy. And I would say that the farmers and ranchers that we talk to from rural areas in the West, they are pro-renewable energy. They want their neighbors to do whatever they want with their land because it's not their business. But they're not anti-coal at all. They're not focused on climate science, but on economic benefits to rural America. And they're probably focused more on weather than on climate, I would say. And so the question often comes up for me, does Jan's community need to know more about climate science? I mean, I would hope so in the future that they will know more. Do they need to? Is it our responsibility to kind of teach them more about climate science? I don't know. That maybe we can maybe talk about that. And then I also wanted to talk about changing minds, and you might have seen a recent article about Jerry Taylor, who used to serve as the climate and environmental policy lead for the Cato Institute. He would argue for climate skepticism. And after being challenged at one of the debates he was in by one of his opponents in the back room, kind of, whom he respected very much, he did more research and dug in and ultimately was convinced that humans are causing climate change and that there's at least enough risk that we shouldn't do nothing. And so I think he did, from the article that I read, he did really try to talk with his immediate colleagues who remained unconvinced. And he eventually left the Cato Institute and now is at Niskanen, but started Niskanen. So I think this is an unusual story where there's somebody who is in the public eye and really switches positions because of the science. I think, unfortunately, that's probably an unusual story. Although I'll say at the center, I was at the National Renewable Energy Lab for 14 years, we saw this, where there were folks from the oil and gas industry who called themselves oil and gas refugees and converts, and they would come and say, listen, I've been doing this for so long, and I get it, and I'm sorry, and how can I help you guys? So it's not a common story, but I think it does happen. I wanted to talk about one more group in Delta County, Colorado. I was recently, a couple days ago, at a meeting by the National Association of County Officials, NACO, and this meeting was a forum for coal-reliant communities. And the coal communities, about, I would say, a minority, but a very vocal minority in that room of about probably 60 people, said, our goal is to fight the war on coal. And one of them said, our goal is to fight the war on carbon emissions, which I hadn't heard before. But most of the people in that room from the coal-reliant communities know that change is happening. And I'm not sure, I don't know what each of them believe on climate science, but there was a story from Delta County. A woman was saying that 8 years ago, there was a fire in a coal mine there, and their coal mine shut overnight, and they lost 800 jobs like that in that little tiny community, which is a huge deal. There are 3 coal mines there, and one of them is gone. And so the people in that community had to rebuild after their coal mine shut down. And she is going around talking to other coal-reliant communities, and she's not bringing up climate science, although she does talk about changes in the climate. So I guess she is bringing up climate science, but she doesn't say climate change. But she's warning them. She's saying, this is going to happen to you too, because coal plants are closing. So how can you be more resilient? Let's think about economic diversification. Let's make sure that the community and the stakeholders that are most important to this process are involved in the decision-making of what comes next for your community. And so I think some people in the room, were hopeful. The Delta County story is really successful. They now have a lot of organic farmers. They have vineyards that they didn't have before. They have companies like they're laying fiber optic cable and things like that. So they've come up with some really innovative solutions. And she's kind of spreading the word, saying, that this change is coming with coal plants closing. So let's use our experience, our bad experience, and help you. there was a guy from rural Arizona who said, you know, coal has kept us fat and happy. He said, we've had people come to our community for 20 years with new ideas. They're using science and technology and innovation, and they want to do these things in our county, but we've said, no thanks, that's okay, we're good. Because coal has kept them fat and happy, he said. And so they have new recreation centers, they have new fire departments, they have, you know, really wonderful park facilities. But that's all because of coal and the tax money that comes from coal. And so he said, I wish we would have listened to those people, because there are great ideas out there. So now we need to open up and be ready for that. And then I wanted to go back to Secretary Moniz last night, read a quote from President Obama about a guy who drives 50 miles to his job. And so gas prices really, really matter to that family. And I've been thinking about that a lot in my work because I work on coal transitions. And I've been listening to podcasts focused on energy, a lot of them out of DC. And one of the things I hear a lot is that rural people are uneducated and that they don't get it, and they're just going to have to come along with the energy transition. But I'll tell you, I don't know how to fix a tractor. And I'm really thankful that my food, you know, comes from the farmers. And I think we have to be careful, especially when we're like on a national podcast or international podcast or something. And you know, these problems are real, and I think people care more about weather because it's right in front of them than they care about climate because they're worried about feeding their families today. And so I do see in the rural communities we work with change coming from the younger people, and I'm hoping, Anne, that some of them have been educated on some of the things you're talking about. But I think with younger generations, we are going to start seeing change, but there's really big resistance to it too. And if I tried to talk to, there was a guy from Wyoming who said, the problem is the windmills. He said the government is giving so much money to wind power. If we gave just as much money to coal, we'd be fine. And that's not true. Of course, we all know that. And if you look at, you know, a chart of government subsidies over the years, you know, we all know that would look different. And he's maybe referring to the production tax credit, which is winding down. But if I went and talked to him about it and showed him the science, I'm not sure if that would convince him. You know, I think he's got it in his mind that the government, he said, the green wave coming from Washington right now, you know, and I thought, oh my gosh. But he's got all these misunderstandings, right? And I'm not sure sitting down with him and having a conversation about science would work. I do think that over time, we have shared values. We both care about the land. We both care about our kids. So we do have shared values. So I do think over time I could work with him. And that's one important thing we've learned also about working with rural communities is that it takes a lot of time, right? You have to sit down at their kitchen table and really meet them where they are and keep coming back. You can't just go talk to them and then leave, which is, you know, what I've been doing most of my career is I give a talk and then I walk off stage and then that's it. But maybe we have to think about a way that we can spend more time with people. And I'm not sure how that looks because that takes more money as well. But maybe that is also food for discussion. So anyway, there's some top-down and bottom-up examples from the Center for the New Energy Economy, and I look forward to our discussion.
Good morning, everybody. Let me start with a few pieces of housekeeping and a couple of confessions. First, having worked in the Environmental Protection Agency for 7.5 years, this is one of my first experiences appearing in public without 40 slides. So this is definitely, you're watching me perpetrate what for me is an unnatural act. So please be indulgent. The other thing I wanted to say is that I'm really very grateful to be here at a AAAS event because my experience with AAAS as a result of having worked on Capitol Hill and in the Environmental Protection Agency is having had the opportunity to work with AAAS fellows. It doesn't take any provocation for me to observe that the people I worked with at the Environmental Protection Agency, that is the career staff, in my view, like many federal employees, are pretty much the finest people that our society produces. And among them are AAAS fellowship alums. All over Washington, I've had the privilege to work with people who are really outstanding. And I actually developed a mental habit when I was introduced to or able to work with somebody who really struck me as impressive, was to ask myself silently, I wonder if this person was ever a AAAS fellow. And very often the answer turned out to be yes. So let me just if you remember nothing else from what I say, please do remember that this is one of the great programs that contributes to Washington, D.C., to policymaking and to society. The perspective I'm bringing to this topic, which is the interaction between climate science and policy, flows directly from the time I spent at the Environmental Protection Agency during the Obama administration. I would argue that the interaction between science and policy is not determined by or under the control of the science community. Rather, it is determined by whether or not, let's say in this case, the federal government continues to adhere to the principles of sound governance. And I think I can testify to the fact that during the Obama administration, and I think most administrations before then, the principles of sound governance created an entirely hospitable environment for science. The at least executive branch policymakers, whether they know it or not at the beginning, are compelled by legal obligations and by the institutions that Congress implicitly built in enacting statutes, say, like the Clean Air Act. These government institutions, ultimately, as they got built, say, starting in the 70s, 80s, and 90s, as environmental statutes were being enacted and implemented, they were built in ways that closely mimicked science itself. What I mean by that is this. Whenever the federal government, I'm going to be using the Environmental Protection Agency and the Clean Air Act as examples, because that's what I know, takes an action, it must, in the end, be able to defend that action against well-resourced, often good faith, motivated critics of that action, and then subject that action to judicial scrutiny. That experience, that institutional experience over the decades, means that agencies like, again, the EPA, are themselves, just like scientists, engaged in a process of perpetual curiosity. What you do in government when you are engaged in sound governance is put a premium on information gathering, you put a premium on analysis, you put a premium on examining questions from a, let's say, 360-degree perspective. And in fact, when the government functions well in this context, the government sort of has the same experience that, say, Anne Reid students do following the rubric of asking questions, figuring out what methods to use to answer the question, and then in an immediate, hands-on way, perform investigations. Now, to my mind, you reach a point when you're undertaking that kind of governance where the methods of governance and the methods of science are virtually indistinguishable from each other. At least that was my experience when I was at the Environmental Protection Agency. So, for example, climate science, if you will, was brought to bear in a governance and policy-making context in 2009, when then Administrator Lisa Jackson signed what's known as the endangerment finding. The endangerment finding was a determination following a specific statutory provision that had been interpreted by the Supreme Court that greenhouse gases, or as we put it at the time, well-mixed greenhouse gases, presented a danger to public health and the environment, and did so in a way that was actionable. That is to say, it was a danger of a sort that triggered a specific policy action under a specific provision of the Clean Air Act. And what the agency did was what it had been trained by other parts of the Clean Air Act to do for decades. The agency had been charged by Congress with setting national ambient air quality standards for conventional pollutants like fine particles and ozone, and over the decades had built an extensive, multi-stage, if you will, scientific process for setting those standards. And the agency took all the know-how that it had generated through that set of functions and applied it to the science question: do well-mixed greenhouse gases present a threat to public health and the environment? And as it turns out, the agency determined that the answer to that question was yes. Again, having gone through an extensive analytic process of looking at, if you will, all the evidence that science had assembled across the diverse range of methods and approaches and types of studies that science had used. Why did the agency do that? Well, it's good practice, but also the agency knew that it couldn't simply assert the conclusion. It would first have to, in fact, what happened is it proposed the conclusion, it took public comment, it analyzed the comment, it developed, if you will, massive brief informed by and in response to the comment, and then issued a final endangerment finding, and then was compelled by law and the petitions of critics and opponents to defend that entire process, as well as the conclusion in federal courts, all the way up to the Supreme Court. So there is, in recent history, a model for merging, if you will, or marrying the bread and butter or the bedrock of science and policy decision-making. But if you accept my hypothesis, what made it go was not science on its own, exerting unilateral powers, but it was the fact that science was blessed with the opportunity to operate in institutions that had built themselves in response to the demands of science. That's the good news. The good news is we know how to do this. The bad news is that we are in the midst of a fundamental crisis of governance at the federal level. And again, this can be, I think, understood quite well looking through the lens of science. The current Trump appointees at the EPA have a disturbingly good sense of what science is. They have a disturbingly good understanding that science, in its dynamism, is disruptive, subversive, and inimical to very powerful societal interests. They understand science well enough to have launched on a program to deconstruct the Environmental Protection Agency's ability to conduct sound science. So, for example, again, the lifeblood of one of the agency's key functions is setting ambient air quality standards for conventional pollutants like fine particles and ozone. Up until the arrival of the current administration, the agency had built and relied on a multi-stage apparatus in terms of science panels and a multifaceted methodology for gathering scientific information. And in the last 18 months, the agency has methodically taken that apparatus apart. And in March, the science so-called leadership of the agency launched a frontal attack on some of the basic methodologies of how the agency had done science. And so what I think we're observing now is, again, not a crisis of science, but a contest between the values of science as they are almost synonymous with the values of good governance, and a concerted effort coming on the other side to attack those values directly. I know we should probably open this up to discussion, so let me just throw out a few references. The program I operate now at Harvard Law School is operating a project where we are tracking the attack on governance that's taking place in the Department of Interior and the EPA. We have a fairly extensive website documenting this, and one of the pages focuses on specifically the attack on science as an attack on governance. The other thing I'd like to suggest, and I think I can ask the organizers of this conference to get this information out, is that everybody take a chance to read an article that was published in Science magazine at the end of March by Francesca Domenici of the Harvard School of Public Health and Gretchen Goldman of the Union of Concerned Scientists, who describe, I think, very effectively what's been going on in terms of the frontal attack on science as it's applied to setting air pollution standards. And that the recent events at the agency were described by one of the authors of this piece, Gretchen Goldman, on a blog post that she put up at the end of March. And also, of course, I think if you take a look at the Harvard Law School Environmental Law Program's governance study, you'll see, some evidence of what I'm talking about and how it's described. Let me just wrap up by saying that, obviously what I'm discussing is not a problem of science, it's a problem of politics. And I think that my colleagues on this panel, whether they realize it or not, are using some extremely clever and it sounds like very effective strategies to get at this problem by mobilizing our fellow citizens to, if not to understand what's going on, then to develop the kinds of mental habits that our fellow citizens would benefit from and would help, at least indirectly, protect science from what's going on at the federal level. But I unfortunately have to leave you with the message that unless and until they succeed completely, we're in a lot of trouble.
I'm sure I knew we were going to end the panel with the phrase, "We're in a lot of trouble." So let's try and spin off that. I'm going to ask like one or two questions and we'll go to the audience. And let me ask, I want to forward cast a little bit here and I'll make some of my thoughts transparent, but I was sort of very fascinated with Ann's sort of example of the learning moments and how to structure that I remember the sticking the myths, getting rid of the sticky myths and process. I also noted in Ann's slide that Alaska is red on your climate, level of acceptance of human-caused climate change, and it's because Alaska, of course, is seeing the effects. I think common understood because of Alaska is seeing the effects of climate change, even though its politics are much more conservative. So I think you could, and the last thing is thinking back to Ernie Moniz's speech last night, there are things we can do and justify basically on economic grounds as renewables become more competitive, but there are things that we will do to deal with the scope of this problem that we only do if we understand the science of climate change. We only pursue carbon capture technologies, really, if we realize that this pollutant is causing us harm. So I think we eventually need to persuade society that we have to take these issues. So looking forward, if Alaska is red, it may forecast that the rest of the country will turn redder as we feel the impacts. Does that foreshadow an open-mindedness to have this conversation? And if so, how do we create content and create metaphorical classrooms for our society to do that? So as Suzanne, you bring in legislators who may be warming, no pun intended, to these ideas, as Joe, as our colleagues' efforts help legislators and the federal government how do we create those learning environments, that sort of sustained engagement that can happen in a science classroom? How do we bring that metaphorically to our policymakers? It's a big question, but I'm thinking, I was taken with Ann's sort of approach with the interactive tool, and how can we find context in which we can bring that to policymakers as well?
So I would say, I guess, two things. Let's bring it to policymakers. And we talked about this a little bit on the phone, but it doesn't look like it takes very long. And there are policymakers who'd be willing to engage, I think, in that. There are definitely policymakers who wouldn't be also. And I find it effective to show slides of disasters. I think a lot of people are maybe impacted by, the flooding and hurricanes and things like that, and when you can sort of relate those two. Because I know, and I guess this is so I know from working with members in my own community, for example, I have a daughter in second grade, and she was working on a science project with one of her friends, and they were working on this project, and my daughter was writing on their poster board, and her friend said, "Don't put too many words on it because, we want to make it pop." And so I thought this was really funny and kind of cute, cute, and I was telling her parents about this, and they were like, yeah, some of the posters have so many words. They're really boring. And I just thought, well, this is a science fair. What's going on here? But it's, well, my daughter thought it was really exciting. The birds are really exciting too. So it's just, these people are, we're politically very much the same. We're kind of in the same income bracket. We work in the same community. The dad is our soccer coach. But they're not interested really in all these words and graphs and things like that. You know, they want to either hear a story or they want to see a photo, you know, that wakes them up or something like that. So I guess that's just included in that is I think there are people who would be willing, and then there are people who wouldn't. And then my second quick thing is I know when I was young, my mom smoked, and I would take her cigarettes out and I would break them and then put them back in the box, but she still gets mad at me for it, even though she hasn't smoked in a really long time. But you know, the smoking, with smoking, we've really decreased the levels of cigarette use, right, among adults, and a lot of that was a different generation coming in and saying, you know, this is really bad, parents. And same with recycling, I think. I remember when I was in college, I would go around and educate people in my community in Madison, Wisconsin about recycling. And I would teach them about recycling, and the young people were like, Mom, you can't throw away that can, you know, and that really helped with the sort of generational shift. And we can't wait a generation. I know we don't have that long, but I'm really appreciative of the work that you're doing, and I feel like with the younger generations who are like, well, of course climate change is real. You know, parents are, it helps educate the parents through the children. And that's not the only answer, but it's one of them.
I'm thinking back to a talk yesterday with Vanessa Chan about the soft skills that she's trying to give her engineering students, and that's really what we're talking about here, is that you have to establish an environment where people feel comfortable sharing their ideas, asking questions, not being made to feel like outsiders, that here's the scientists over here and here's the public over there. That trust, and that this is run through a lot of the talks over these 2 days, that establishing trust, establishing some shared values is the first step. People can get really, really excited about rather sophisticated and nerdy things in surprising ways. And we have a colleague at UC Davis who teaches statistics entirely using baseball. Because a lot of people can really get excited about sophisticated statistical techniques if it's going to help them, you know, with their fantasy baseball team. So, and I'm fine with that. You know, I think that, and I think that the same is true of climate change. You can get people interested in what's going to happen to my town, and you don't make it a condition that first they accept your opinion, but that you say, wouldn't you want all of our policies to be based on the best facts that we have, and establish that as the starting point? And then, you know, I have great confidence in the evidence. It's extraordinarily rich and deep and convincing. So if you can just open that door a little bit, or as my predecessor always says, you get people's fingers out of their ears, the evidence will be extremely convincing, but you have to establish trust first.
So I think I want to add a little bit to that. So you mentioned Alaska. So one thing that we found is that we have a number of experiments and facilities that are actually sited in Alaska. And we've been there for quite some time. And what we've done is we found it's one thing to kind of scare people into doing the right thing, sort of like smoking, right? But it's another thing to actually engage them in the actual work. And so what we've done with some of our long-term field studies, you know, we will go out to the community and we will ask their opinions. We'll have kind of little community town halls where, you know, we'll have some citizen science where they can actually participate in collecting samples. And I think that, you know, people care about where they live, and, you know, they don't necessarily want to buy into a big philosophy or political statement, because that's kind of too much. And so, but what people want to do is they want to understand what's happening right around them and what can they do to help their own community, like the farmers. And so I think that we found that using that sort of softer approach actually works. And then we can go back when we go to the Hill. You know, we can then have some stories. And so certainly everyone we've encountered in Alaska has been very positive. The staffers have been positive. The senators have actually been very positive about the work that we're doing there. So we've never actually encountered any resistance because we're not sort of taking it head on and inviting conflict directly.
I'm actually gonna relent and go to the audience. So, question?
Hi. I'm Julie Stallhut. I'm a AAAS Science Policy Fellow at NSF. And I really, am always heartened when both experts and interested citizens get into the task of educating, their neighbors. But I also follow on Twitter Katharine Hayhoe. For people in the audience who don't know who she is, she's a climate scientist at Texas Tech, does a lot of media outreach, does a lot of outreach to faith communities, of which she's a member of one. And in order to do that, she has had to put up with death threats and unbelievably vile personal abuse, and she's very good at coping with it. But a lot of people who have her level of expertise and interest and desire to help really are not, it's a really tough thing, I think, when you have people insulting and threatening you on social media. How would you encourage us to support people who are willing to step up and have the kind of personality that can cope with that?
Katharine Hayhoe is a hero. She's fantastic, and she really models this approach of first we establish shared values, and then we go out and we solve the problem together. And at a very small and local level, science teachers in conservative and evangelical communities are doing that same thing every day. And they probably, most of them don't get death threats, but they sure get a lot of pushback from their communities. And so helping people, we teach something called the no conflict approach that helps to forestall that kind of conflict. I'm afraid that there is bringing a no conflict approach to the internet. It drives everyone to the bottom. But in person, it's very effective to just refuse to engage in a debate, and instead to continually walk back to a place where you have a shared value and a common interest. So I think that we can all, and we had, Andrea asked how people who don't consider themselves scientists can get involved, and I think the answer is you find the issue that you care about, you run for school board, you go to every meeting of your local water quality board, you insert yourself into places in your community where you want science to be considered as part of the policymaking process, and you demand that it happens. We can all do that, and that will help protect the people who are out there, trying to teach or trying to advocate and facing hostility.
Can I add a few things? I follow Katharine Hayhoe religiously, no pun intended. And one of the things that is really striking about her work, and a lot of it's on elaborate but easy to follow Twitter threads, is that she puts the agenda in the background, and she foregrounds her core expertise as a scientist. And as it happens in my current work, I spend a lot of time not just with law students, but with science grad students. And they are haunted, many of them are in the physical sciences and focus on climate. They're haunted by the frustration of seeing how slowly we're responding on a national policy level. And they often ask me questions or seek career advice that strikes me as they're trying to shade the work they do as scientists into more of a service of the broader policy agenda. And my recommendation is not to do that. And I think it goes to the question you asked, which is, what is the root of your courage? The root of your courage as scientists is your faith
to science. It's not your agenda to try to persuade third-party non-scientists to take actions. The root of your courage is your strength. It's your faithfulness to science. And for scientists who are wondering whether they can follow in the path of someone like Katharine Hayhoe, I would suggest adopting that approach.
We go to the next question.
Good morning. My name is Kevin Blake. I'm a graduate student at Washington University in St. Louis. And so, of course, when I saw the heat map come up, I, of course, looked to Missouri and was a little dismayed to see St. Louis was a very tall, small speck of red in a sea of blue. And I think we've talked a lot today about impacting your local communities, but how can, especially in regions of the Midwest, where a lot of those reds are very concentrated dots, influence the communities around it at a much larger reach?
I promise I didn't pay him to ask that question, but we actually have a program directly aimed at that, providing graduate students at universities surrounded by largely rural areas and how to do effective science outreach. And a lot of graduate students are really interested in broader impacts, in communication, in activism, and they're often not very good at it. And they're not very good at talking to the public about science, and they're also not very connected to those communities. And again, since the first step is always establishing trust, they need to be guided along the process of how do you start doing outreach in a community like that in a way that's going to be successful. We have a fellowship for graduate students, a year-long fellowship where they learn those skills and go out and start doing climate change and evolution focused activities in the communities around their universities. I think it's, we are striving always to be evidence-based ourselves, so we're assessing the program to make sure that the graduate students really do get better at what they're doing, that they become more effective communicators, that they know more about the community that they're working in. But early signs are that it really is very effective, and so I'd love to talk to you about whether there are graduate students at WashU who would want to participate in something like that.
I would add that there are issues that are really important. Certainly in the West, water is one of them. And so if you can talk to people about the issues that are the most important to them that have to do with science, and in particular, I guess, for me, with climate change and climate science, sometimes it's not atmospheric conditions, but it's, something like their local waterway, or, and I would just say also, there are a lot of, people concentrated in certain areas, but you're not necessarily from that city, and so talk to your neighbors back home, talk to your community that you're from. That's also really helpful because they trust you. You're from there, and so they're going to listen to you. And you have to spend time with them. Is one of the issues I'm sure you find too, that you can go and communicate a little bit, but if you're not sitting down with them on a more regular basis, then there's an us and them. That you're not one of them. So if you can spend some time, I think that helps too.
Thank you. Next question.
Hi, everyone. Thank you for the panel. I'm Jennifer Tribble. I'm from Duke SciPol. My question is about sort of the magnitude of this problem that I think you've all alluded to. I think climate change is really big, and there are fewer wins than we might like, and even when those wins occur, it's really hard to tie that to tangible outcomes. We're still bombarded with really negative news all the time. So my question is, how do we foster a sense of personal resiliency in the educators and the policymakers and the advocates to ensure that we have this sustained long-term fight against climate change?
So one of the challenges in education is teaching about climate change without driving the students to despair. And so the last lesson in our series is that there actually are lots of things that we can do about it. We base that lesson on Project Drawdown that provides all kinds of evidence of all of the different kinds of interventions that people can take and how big of an impact they'll have. And I think Katharine Hayhoe also takes this approach that if you give people a little sense of agency and a little sense that things that they do can make a difference, then they buy into bigger changes. It can't be drive-by, you've got to spend time, and it is going to be complicated, and that was really the take-home from Dr. Moniz's talk last night, that you can't just say, well, let's just do solar, and that'll fix it. That's not enough, but it's good. So, you don't do anything because one simple solution isn't going to work, but it's a welcoming people in rather than talking down to them and saying, let's work on this together. What do you care about, and what are the options for that? And then, if everybody did a little bit of that, we're gonna hold hands and sing Kumbaya now. But it really would make a tremendous difference.
It can be done. I've been working on climate change policy since 1987. It'll come out.
Oh, you just stated But what was the last phrase of your speech?
I have not been working successfully.
So I want to add to that. So I've actually been through 4 different administrations now. And certainly those all come in very different flavors, right? And my experience of them and what I had to do was quite different, also because my job changed. But when I looked at some of the investments that the Department of Energy has made, and so those are basically rooted in policy, right? Because policy tells you where to spend your money. Some of those have been long-standing, and they've been going on from before I joined, right? It's hard for me to imagine that far back, but even before then. And so I think that it's always easy to focus on sort of the negative that's right in front of you, but if you look back at the accumulation of scientific success, I mean, look at these models. We're no longer just looking at 2 components that are just 2 blocks interacting. We're really trying to get down at what happens if permafrost melts and there's a big outgassing of methane. So we're getting down to and the fact that we have tools and we have people who are willing to go and do that science is a really positive thing. And I think that thinking about what's your piece that you can do, what inspires you to kind of contribute to that, because in the end, scientists are part of the public too. So,
and I guess I would add, so there's at CU Boulder, there's a group led by Max Boykoff, Boykoff, and they use humor to talk about climate change, and it's been great. It's kind of, I feel like it's a new thing. He studies the media and climate change. He's a professor there, but they've been having kind of stand-up comedy about climate change, and it's not awkward and weird. It's really funny. So you could look him up, and then I guess I would say there's a lot to celebrate. That states are making really big progress. Maine just joined that list, but New Mexico and Washington and California and Hawaii. So we've got states that are making really big progress, at least on their energy-related goals. And Washington's includes transportation, which we now know is the biggest issue. That's a really important one. But I think there's that to celebrate. Corporations are increasingly, especially international corporations, they get it. They are buying renewable energy. Oil companies are switching, from some of their oil investments to offshore wind, for example. And that's not in huge amounts, but they also get it, I think. And then cities are making changes all over the country, like we saw in Dr. Moniz's slides yesterday. And so I spent 3 summer seasons in Antarctica, and am now really fascinated by all the melting and the change that I could sort of see down there. But you read about it and see the big ice shelves kind of calving off. And one of the things that I do in my local communities, I teach school kids just on my own time about Antarctica and kind of the connection with climate change. And they love it. They love putting on the big red parka and that kind of thing. But then they're also hearing about climate change. And just to leave you with a quick story of hope, I was teaching a 2nd grade class, and I also talked about wind power because that's what I studied at NREL. And he said, how the wind is higher when you climb a mountain, like at the top it's really windy? And I said, yeah. And he this is a 2nd grader, he said, well, why don't we put wind turbines on the end of like a string or something, a kite, and we could have the turbines way up where it's really windy. And I jumped up and down. I was like, it took us 200 years to think of this, and here you are, and you're in 2nd grade, and you just thought of this right now. I want to hear the rest of your ideas. He was really excited, the class was really excited, but it made me so hopeful, because I thought, they don't have the boxes on yet, and so they're really thinking. So anyway, there's a little bit of hope, I think, in the next generation.
I know we're at time. We do have one more person that's standing, so I think I'll take one more question, if that's okay. I just want to underline that I've seen the path in working on this issue for people who do go straight from denial to despair so quickly, and it's stopping in the middle in hope and the sort of the sentiment that we can handle this. That's very important, and now we talk about it. And I do think that there are trends in markets and governments all over the place that show us that if we actually cross a tipping point, we actually will be able to scale this problem. But anyway, let me let the last question come forward.
Hi, Hannah Fry, also from Washington University in St. Louis. And so as a scientist who grew up in the Midwest at a major research university in the region, I'm seeing many other scientists coming in from all across the world who really don't know the region. And they know the science, I know the science, we all are on the same page of that, but often when they try and communicate with the community, instead of getting their point across, I feel a lot of them are doing a lot more to alienate the community than to necessarily bring them in. So this has been touched on a bit, but I just wanted to hear more about how we can talk with local activists and kind of shift the gaze of education from the community to actually educating activists to how to better reach the communities.
Great. Let me let you guys revisit those things and maybe quickly, so can we let everybody get to the break?
Well, the mantra of science communications is a simple message repeated often from a variety of trusted sources. And you're not going to be trusted if you don't get to know the people in your community. I think we've heard that over and over again, and really go out and seek allies. When we talk, okay, you were talking about underrepresented groups in science, and we don't often think that evangelical Christians are hugely underrepresented in science. Republicans are hugely underrepresented in science. And so when we go out to look for those trusted messengers in our community, we don't find them. And I think that that's part of the problem for science to think about too. And you're absolutely right. We could do more harm than good if we go out and talk down to people. So learning those soft skills is really important.
The professional societies have a number of training tools to teach people how to communicate with various different kinds of stakeholders. And so I know AGU has offers some of those. I know AAAS has some webinars that are even online. And I think combining that along with broadening your network so that you get to know people who are right on the ground and then include them in the discussion so that they can then be ambassadors. I think that's kind of like start small, but I think it is effective. So even in the Midwest, why should people in the Midwest care about climate? We fund a lot of agricultural modeling there. And so people want to grow things, and they want to know what's the water going to be like, what's the temperature going to be like, so that we can buy our seed, we can plan for years to come. And that's all part of what goes into studying the climate. So I think there's a way to kind of hit it from a number of angles to make people care about it.
Science is potentially highly participatory, as is aspects of policymaking as well. So using processes where you are enlisting who you think is the audience, initially think of as the audience, to actually be the participants in the inquiry, as Anne's work, in fact, everyone's work up here demonstrates, I think is the key. As Anne illustrated, and start with the question and ask everybody to answer it. When I was at the EPA, we used that process a lot on policy issues, and it was astoundingly successful when we got to the Supreme Court.
Jerry, you've now secured a last line for the whole panel as well. All right, please join me in thanking my colleagues for a wonderful time. And I will firmly, we are on break until 11 o'clock where we will return to this room, correct? Thank you.